roots. So, to calculate the area of a square, if we think back to geometry in 6th and 7th grade, we would use the formula side times side as shown in the diagram below. So if I had this square, these two side lengths are the same, and I would just multiply that side length times itself to get the area of this square. Side times side. Well, if you think back to 6th grade and your exponent rules, when you multiply a base times itself, we can write that using an exponent. So since this is a side and this is the same side, I could change that to be side to the power of 2, or side squared. So therefore, when we are discussing raising a base to a power of 2, we can say we are squaring a number. So if we raise that power to an exponent of 2, we are squaring the number, because side times side is the area of a square. Side times side is the same thing as s to the power of 2, or s squared. So that's squaring a number. So a square is the solution or area calculated when raising a number to the exponent of 2. Here, 5 squared, well, the square would be 25, because 5 times 5 is equal to 25. You can see that here in the grid. If I do 5 times 5, I get a 25 square grid. 25 is the square because it's the solution. It's the answer when I raise 5 to the exponent of 2, or 5 times 5, 25. 5 squared is 25. Remember, when you raise something to an exponent, that is not multiplying that exponent by the base. Instead, you are basically saying, okay, if I have an exponent of 2, that means I have 2 5s multiplied together, and that's squaring something. A square root, on the other hand, is when we do the opposite. So a root, or a side length, remember if we think back to a square, that was the area, okay? A square root is going to be your side length that is being raised to an exponent of 2. In other words, a root is a number that can be multiplied by itself to create a square. So here, 5 squared, 5 is your root, okay? Because it's being raised to the exponent of 2, and 5 times 5 is equal to 25. If I multiply 5 by itself, 5 times 5, it's 25. Square roots are denoted using a radical sign. So here we go. We have the square root of 16. This symbol, it kind of looks like the divide symbol. This means the square root of 16, and as we just mentioned, we're looking for a root that's a number times itself that equals 16. Well, our answer to the square root of 16 would be plus or minus 4. And the reason I have to include this plus or minus sign is because positive 4 times positive 4 is 16. And then if we think back to our madman or integer rules, a negative times a negative is a positive. So negative 4 times negative 4 is equal to 16. The meaning of a square root is a number multiplied by itself. Well, negative 4 times negative 4, it's the same number, still equals 16, so it is also a root of the square root of 16. The reason we have the plus minus sign is because a positive answer works, 4 times 4, and a negative answer works to equal 16. Remember, the square root is the number you multiply by itself to get whatever is underneath this radical sign. So perfect squares, okay? These are things that you multiply a number times itself and it gets you another number. That's a perfect square. It's the product of a number times itself. When we talk about squares and square roots, we're really talking about multiplication. So only perfect squares will result in rational square roots. Now we'll talk about that a little bit later when we get into the real number system. But if I take the square root of a number that is not a perfect square, I'm going to get an irrational answer. So we don't need to worry about that right now. We will talk about that in a couple of days. But for right now, we are going to look at the perfect squares. So a perfect square starting with 1 squared, well, that's 1 times 1, which is 1. 2 squared, that's 2 times 2, which is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 48, or is 64. 9 squared, 9 times 9 is 81. 10 squared, 10 times 10 is 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is 144. 13 squared, 13 times 13 is 169. 14 squared, 14 times 14 is 196. And 15 squared, 15 times 15 is 225. I expect you to have these memorized through 12 squared. Those are your basic multiplication facts. You need to know these. I'm just asking you to add on these. Now, obviously, you have your calculator. You will be able to type them in, but it will make your work go a lot faster if you know what the first 12 perfect squares are. Okay? So now what we're going to do is we're going to solve some problems using perfect squares. Now, the first thing you want to do is simplify before you start doing square roots. So this first one, I have 46 minus 10. That's all underneath the radical sign. So I'm going to do 46 minus 10. Well, that's 36. And then it's saying the square root of 36. Well, the square root of 36 is positive and negative 6. Remember why we have that plus minus sign is because positive 6 times positive 6 is 36. And the definition of a square root is a number times itself that equals it. And negative 6 times negative 6 also equals 36. Here, I don't have anything to do under the radicals. All I see is that I have the square root of 100 divided by the square root of 25. So I'm going to go ahead and simplify the numerator and the denominator first, and then simplify the fraction. So the square root of 100 is plus or minus 10, and the square root of 25 is plus or minus 5. Well, I can simplify that further. Plus or minus 10 divided by plus or minus 5, well, that's just plus or minus 2. You would have got the same answer if you had divided the square roots first, but it's easier to do what's under the radical before you move on. Practicing again, because I have this addition, whenever you have addition or subtraction, you do that first. If it's multiplication or division, simplify the radical first. So here I have addition, so I'm going to add these together. 9 plus 16 is 25, so I have the square root of 25. The square root of 25 is plus or minus 5. Remember, you have to have your plus or minus sign. And that is my answer. Here, when you have a number outside the radical sign, it's basically like saying there's hidden parentheses around this. So what I'm saying is 8 times the square root of 49. Well, the square root of 49 is plus or minus 7. So I have 8 times plus or minus 7, which results in plus or minus 56. Whenever you have a number outside the square root sign, it's just multiplied by whatever the square root of that number is. Okay, estimating perfect squares, or estimating square roots. If there is not a perfect square, remember a perfect square is a number times itself. If there's not a perfect square under the radical, the answer will be an irrational number. Thus, the decimal will not terminate, that means it won't end, or repeat. So we will need to estimate the answer. A prime example of an irrational number is pi. You talked about that in 7th grade. You know all the decimals of pi just keep going and going and going on forever. And that's basically what an irrational number is. So if I took the square root of 2, that will give me an irrational number because it's going to be a decimal that goes on forever and does not repeat, similarly to the number pi. So we're going to estimate these square roots. Well, what do I mean by estimating? 6 I can see is not a perfect square because I cannot think of any number times itself that would equal 6. So instead, I'm going to estimate which 2 integers the square root of 6 is going to be in between. Well, I know that the square root of 6 is in between the square root of 4 and the square root of 9 because the number 6 falls between 4 and 9. 4 is a perfect square because the square root of 4 is plus or minus 2. And 9 is a perfect square because the square root of 9 is plus or minus 3. So I know that the answer to the square root of 6 has to fall between plus or minus 2 and plus or minus 3. If I type the square root of 6 into the calculator, how you type a square root sign into the calculator is you're going to press second, which is the blue button, and then the x squared button, second x squared, and you should get the radical sign. If I type that into the calculator, I see that the answer to the square root of 6 is about 2.4, so it's slightly closer to 2. You can also reason that through in that the number 6 is a little bit closer to 4 than it is to 9, because 6 is only 2 numbers away from 4, but it's 3 numbers away from 9. So our answer should be closer to the square root of 4, which is 2. If I was asking you to estimate, I'm asking you which 2 integers is this between, so your answers would be plus or minus 2 and plus or minus 3. Here we go, we're estimating again the square root of 30. Well, 30 is between the square root of 25 and the square root of 36. 30 is not a perfect square, but it's in between those. So it's going to be pretty much in the middle because it's 5 numbers away from 25 and 6 numbers away from 36. The square root of 25 is plus or minus 5, and the square root of 36 is plus or minus 6. So I know for a fact that our answer for the square root of 30 is between plus or minus 5 and plus or minus 6. If I type the square root of 30 into the calculator, I get 5.5, which is pretty much slap bang in the middle like we said it was going to be. And last but not least, we have the square root of 115. Well, the square root of 115 is between the square root of 100 and 121. So it's going to be between the square root of 100 and the square root of 121. The square root of 100 is plus or minus 10. The square root of 121 is plus or minus 11. 115 is closer to 121 than it is to 100, so our answer should be closer to plus or minus 11. When I type it in the calculator, I get 10.7, which is indeed closer to plus or minus 11. All right, your homework for tonight is 0.2 squares and square roots. It is due on block day, and on block day, you are going to have a progress check over this homework assignment, so make sure it is completed. Thank you. Have a great day.